diagram here. So we have the false positive rate and true positive rate. So false positive rate should be reduced and true positive rate should be up. Okay. So now what we can do it, we can have a plot on the horizontal axis, and that is what we know that x-axis. We follow the false positive rate. What can be the value of maximum false positive rate will be 1. So then let's say false positive rate from 0 to 1, and what we do is true positive rate we plot along the vertical axis, as we say y-axis. Okay, so false positive rate on the x-axis and true positive rate on the y-axis. Now we have three classifier A, B, C and D. We got the results. Okay, so we have the confusion matrix and we got the results out of this. We obtained the result from the four classifier A, B, C, D. Now we need to understand which classifier is really good among these A, B, C and D. Okay, so now let's say we consider the extreme 4 points, that is the points over the square. Okay, so 0, 0, 1, 0 and 1, 1 and 0, 1. Now if I say 0, 0, it does not match anything. So it is not possible because there should be a test data set and then you should have a total positive class and so on. So when it will be 0, 0, 0, 0 said, when it will be 0, 0, that is positive, false positive. So when it will be 0, 0, false positive rate, when it, true positive rate, when it will be 0. So if the TP is 0, okay, and false positive rate, when it will be 0, FP rate will be 0 when false positive is 0. So therefore, the classifier always says ki all sample belong to negative class. So in that case, false positive rate and true positive rate must be, both will be 0. Okay. So when it will be 0, FP rate, false positive rate, when this part will be 0, similarly true positive rate, when this part will be 0, then 0 plus 0, that means classifier is not predicting any sample belong to positive class. So therefore this is 0.
Hello?
Yes.
Sir, here false positive rate equal to false positive by n, and here total negative value, na?
Yes.
Okay, sir. Thank you.
Yeah, that hopefully this is written. Yeah.
Yes, sir. Yes, sir.
False positive is FP divided by n. Okay. So therefore, when it will be 0, when samples classifier is saying all sample belong to negative class. Okay. So that is the worst classifier, right? So that means you have a testing kit which cannot detect even a single sample belong into the COVID positive. So therefore, that classifier is not going to work. Okay. So therefore, this is 0, 0. Now consider here 1, 0. What is 1, 0? That means which part is 0? That is true positive is 0. Okay. So true positive is 0 here. True positive is 0, and the false positive should be what should be the value of false positive? Divided by false positive is FP divided by all sample. So therefore, false positive will be the all negative sample. So all negative samples are treated as a positive class, and no positive sample actually it can identify. So therefore, false positive rate will be entirely value of n. So then false positive rate will be 1, and whereas true positive will be 0 when if classifier cannot identify even a single sample. Okay. So therefore, so this value will be 1 and this value will be 0. So that is the scenario here. So this value will be 1 and then true positive rate will be 0. So this is essentially also the very bad classifier, because no sample is correctly identified. It is more danger in a sense ki sample we are saying negative sample but we are saying the positive one. So that means all patient whoever coming for testing, that medical algorithm is saying ki it is a positive patient. Okay, so it is COVID positive. So this is also another serious consequence. So therefore we don't want that situation also, that 1 0 is also not useful. So what essentially we want, false positive should be very less. So therefore we should have the value that is false positive is close to 0. And then what do you want, true positive should be quite high. So therefore we should want the classifier which locate within this region. Okay, within this region, not the region which is far away from 0 1. Why 0 1? 0 1 is the false positive rate will be 0, and then 1 means that true positive, everything is rightly identified, all true positive class is rightly identified. Okay, so this is true positive. So therefore a classifier should be, performance of the classifier, that is in terms of the true positive and true negative, should be close to 0.01, not 10. Okay, and if it is away from this point, so it is away from this point means that is not good classifier. Now consider a scenario that is 1 1. When it will be 1 1? True positive, all rightly predicted as positive class, that is true positive. So there is no false negative is 0. And then false positive, when this part will be 0, when this part will be the value of n, when all negative sample will be considered as a positive class. So this is a extreme scenario, that whoever coming for testing, we are saying that all patient are key positive patient. So therefore this part is also the entire value of FP is nothing but the all negative sample also we are saying key positive class, and here obviously positive class is also saying positive class. Okay, so therefore what will be the precision? Precision will be very vast. Say suppose it is, let's say P is equal to 100 sample and N equal to some 100 sample, then precision will be 50%. So this is also we don't want. Okay, so in general what will happen, actually positive sample is much lower in this case, say COVID-19, with compared to the negative sample. So therefore when you identify the people whoever all coming, that is mixture of positive and negative sample both, and then finally we say ki all sample belongs to positive, all sample belong to positive class. So therefore we will have the AP rate will be 1 and TP rate also will be 1. So this is the extreme scenario here, that all class belong to positive class. So that is in earlier one example we showed ki all belongs to negative sample. Probably this is 1 0 point. So therefore we analyze 0 0. No, I think that is this is 0 0 is like all belong to negative class. This is opposite of that, and this is a scenario 1 0. And then another scenario is 0. When we want is really that false positive will be 0, false positive rate will be 0, and then true positive rate will be 1. So this is the scenario when this part and this part all will be 0. These both will be 0. Then only false positive rate, this will be 0, that is 0, and then true positive rate will be 1. So therefore if the values of a classifier is close to this region, so then that classifier is the best classifier if it has value 0 1. So now what we did it here, we plotted along the x-axis is false positive rate, and along the y-axis we plotted the true positive rate. And there are 5 classifiers in fact. So one classifier is here, that means it has positive rate is above 50%, right? And true positive rate is also is above quite good. But it is just above this line indicates is actually a random classifier. Okay, random classifier, if it sometimes it says it's like a tossing a coin, fair coin. So that line indicates that if any point is above this one, it is better than any random classifier, and then if it is below this one, so it is a it is worse than the random classifier. So whenever you develop a new classification algorithm, essentially you need to compare at least with the random classifier. That means if your classifier accuracy is below the 50%, so no one is going to see that classifier. Okay, so therefore, for if you develop a new classifier, essentially you should compute the what is called the accuracy of with the random classifier. Now you analyze the situation here. Obviously D, as I said, it is close to this region, so D will be the best classifier, and then you can consider A and B. So comparing actually which one is best, which one is better than the A between A and B. So A has some values, say false positive rate is more, but B has false positive rate is more, but it has good precision. Or sorry, good positive rate. That means recall. On the other hand, classifier A is very less false positive rate. False alarm rate is very close, and then it has recall value is quite less. So for comparing this scenario, so what we can do it, we need to go further in detail. That we'll say much later. Okay. So from today's discussion, we learned there is something called confusion matrix. Confusion matrix basically help us to formulate different other metrics which actually help to evaluate the different classifier. Okay, and one is precision is very important. Recall accuracy. Along with that, there is something called ROC curve. So precision is something how many it is related to the precision is related with the classifier preciseness. So therefore, out of the total predicted positive class, how many are really positive, that gives the precision. And on the other hand, recall gives all the column wise. So out of the how many actual positive class classifier retrieves the number of positive samples. So this is precision. Recall along with the two terms is actually positive rate. Positive rate is nothing but recall, and another thing is called false positive rate. So out of the falsely predicted as a positive case, out of the total negative sample is called the false positive rate. Now if you plot these two diagram, you essentially the classifier is a classifier is a good classifier which locates in close to 0, 1 location. So how do you get this value? Say we computed the false positive rate and then we plotted the value over it. So that's all about the ROC curve for the time being. Maybe we will see more later on. So if you have a query, please go ahead for asking the question. Do you have a question? Or you didn't understand?
Sir,
Yes.
yesterday you told that you'll be showing us an example of confusion matrix where all the four like true positive, true negative, false positive, false negative are having some value.
Okay. So without example, it's difficult to understand, right? That is you are saying.
No, yesterday's point I got it. I just want to you were saying this is of utmost importance to learn it like properly. That's why I wanted to just go with one more example.
So you want one example, right?
Yes, sir.
Okay. Yeah, I manage one example. So here on example, okay. So later on I'll share you the source, but please concentrate on this example. So given a sample of 13 picture, 8 of cats and 5 of dogs, where cats belongs to class 1 and the dogs belongs to class 0. So what about that? Actual is, so you give there
Can
are,
you enlarge it a bit?
okay, sure. Is it okay? Now it is okay.
Yeah.
So there are 13 samples or pictures. So 8 pictures belong to class 1 and then 5 belong to class 0. So this is actual class level. Okay. So that is there are 13 sample here. So up to 8 belongs to class 1 and then rest as 0. So assume that a classifier that distinguishes between cats and dog is trained, and we take the 13 pictures and run them through the classifier, and the classifier makes 8 accurate prediction and misses 5. 3 cats wrongly predicted as dog and first 3 prediction and 2 wrongly predicted as cat. Okay. So here, so our model is trained, and these are the class level of the test sample. Okay. So and these are the prediction by the classifier. We feed these sample sequentially. So therefore, so actual class level for the first sample is 1, but classifier predicted as 0. Similarly, it is 1, it predicted as 0. So similarly, it is 1 predicted as 0. Okay. So similarly and so on. Did you understand? Please follow it.
Yes, sir.
Okay. If it is yes, so if it is yes, then we need to draw the confusion matrix. Okay. So how do you do it? So we'll draw it confusion matrix. So we put it or row I is predicted class and column wise is actual class. So cat considered as a positive class and dog is negative class. So here we gave the name, but okay, you can give here positive class and dog is negative class. Now, when you feed the sample, first sample, so first sample, what is the prediction? Prediction is 0. Okay, that means this is saying that it should be predicted as a negative class. So therefore, that sample should come under false negative, right? Am I right?
Yes, sir. Yes, sir.
So false negative. So false negative is 1. Next sample is again a feed and then it is predicted as 0. But what is actual value? Actual value is 1. So it is predicted as negative. So row I, this last row, this is all about the negative class. So negative class coming is 1 more. Then this third one is also wrongly classified as negative class. So it is wrong and it is wrongly classified as it is first is negative class and it is wrong. So therefore it should come here. If it is a negative class rightly classified, it should appear on this true negative. Now come the fourth point. Fourth point, class level is 1 and what is the class level 1? So that means both are agreeing as it is positive class. So here 1 will come here, right? So 1 will come here. Okay, first one. Next or first P. Next, so P is nothing but here P4 actually. Next, what next? And here, what is that? Here is sample, let's say, let me write the sample here. Sample is x4. Here sample will be x1. X2 and x3. Okay. And here is sample x4. Then x5. X5 predicted as 1. And what about this one? 1, 2, 3, 4, 5. That is also. So it is truly predicted. So it should appear here. Next. Next is x6. So 1, 2, 3, 4, 5, 6. It is 1 here. So 1, 2,
1 plus x6.
yeah, I think it is okay, right? It's matched. So then x5, right? 1, 2, 3, 4, 5. x5. Then x6 is 1. This is also 1. x7 is 1. This is also 1. And then x8 is 1. This is also 1. So therefore, 4, 5, 6, 7, 8. So 5 are rightly predicted. Okay. So therefore, it should appear x4, x5, 2, so on. So total number of sample rightly predicted as positive class is 5. Okay. Done. Now here it is 0, 0. 0 is what? Negative class. So this is also negative class. So therefore, prediction is right and it is negative class. It should appear in this region. So here, what should be the case here? So it is the, what is the position? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it should be x9. Okay. Then x10 also negative class. Okay. So then x11, right? So
Yes, sir.
So x11. So that is negative class. Now here we are saying as a positive class, but actually it is negative. So where should it come?
False positive dog below
False
dog.
positive part here. Okay. So therefore it x12 and x13. Done. Here 2, here 3, 5 and 3. So we got the confusion matrix. Okay. So now what will be the precision? Oh, I cannot write about it. So what will be the precision?
Sir, 1 minute.
What will be the precision?
5 by
7.
7.
Precision will be this row.
5
So
upon
it
7.
is positive class 5 by 7. Okay. So this is precision. Okay. So P equal to 5 by 7. Okay. And then what about the recall?
5 by 8.
So 5 by total sample as a positive class. So 5 by 8. So recall will be 5 by 8. Okay, good. Then what next? Accuracy. Accuracy
8 by 13.
8 by 13, sir.
8 by 13. So
8 by
accuracy,
13.
so it will be 8 by 13. Next, what next? What is the true positive rate? PP rate
5 upon
5 by 8.
5 by 8.
So it is,
5 by
it is
8,
nothing
sir.
but recall. Okay.
5 by 8.
And then what about the false positive rate?
2 by
2
5.
by 6.
2 by 5.
So it will be 2 by 5. Done?
Yes, sir.
So this example is taken from the Wikipedia just now. That's all, I think. So in next class we talk about the different. I am leaving you to little early. Otherwise I can continue also. So let me give you the picture what I will be teaching in next. So once do you have any question now? What you can do it. So what will be the if I draw it on ROC curve? What will be the value of that? Can anyone tell me? See, ROC curve is plotted over x and y axis. What will be the value of x and y for this classifier? So false positive rate is what? So this will be 0.4, right? And what will be the value of recall?
0.66.
Point
0.625.
6. I can trust, right? ठीक है. Okay, so then value will be at false positive rate will be on the y-axis and then true positive rate will be 0.625. So it is better than the random classifier. Now you see the where this point belong. Okay, so this point is above 0.4, so therefore this point will be above 0.4 and 625, right? So it is better than the random classifier. Okay. So in the next class, basically we'll be talking about Bayesian classifier. Okay. So here we go. So basically from the data set we can find, and mostly NLP they find the probabilistic relationship between the word to word. So relationship between the attribute set and the class is non-deterministic. In a situation we can use this classifier. Otherwise from the given data set we can also compute the probabilistic value and then we can apply. So here we go. Let's say a doctor knows that meningitis causes stiff neck 50% of the time. So if any person is having meningitis, there is a high chance that his chance is 50% that guy will get the stiff neck. And it is also known that it is very rare that patient is having meningitis. That is 1 by 50,000. And also, in general, without any information, that prior probability, that is traditional information we have key, prior probability of any patient having stiff neck is 1 by 20. It is good, it is better than that having meningitis, but this value is 1 by 20. Okay. So now question is, if the person is having stiff neck, okay, can you predict that what will be the probability that the person will get the meningitis? Okay, did you get the question? So given that meningitis that lead to stiff neck, so we know that person is having the meningitis. What is the probability of being in a stiff neck position? Okay, so in the other way, can you tell that if the person is having stiff neck, what is the probability that he will get the meningitis? Giving this all three information. So this is all about the Bayes rule that will be discussed in next class. Okay. So with that, I conclude today's class. So one point here, but still you can attend the courses is going on. So there are only 50 to 60 participants. So there are space, so you can also attend if you like. But hardly I see the students from my institute. So, but there are quite good number of faculties who are giving lectures. So if you like, still you can attend. So there is no mandatory. But if you feel that you will be working later on in the area of NLP, so you should work. If you don't feel also you can work. Studying is nothing harmful, so it may help you later in some different aspect. Okay, and nowadays NLP is one big research area, so it may help you your placement. I don't know exactly, but I think you will be benefited in other way around. Okay, so with this suggestion knowledge lecture, I finish today's talk.